I guess let's get started here. So in 3.2 we learned about plugging in stuff, and that's kind of what we did in 3.2. We just learned how to plug in things. We learned how to plug in for x, we learned how to plug in for y. It doesn't really matter which one you plug into. If you plug a number in for x, you can get the value for y. If you plug a value for y, you get a value for x. So it just went vice versa. Now we finally get to graphing here. And so 3.3, as we start, we have to graph 2x plus 3y equals 6. Well, here's what we'll do. We're just going to make a little chart. And the homework says plug in 3 points. And again, it's whatever you want to plug in. You decide which ones you want to plug in. But as we talked about earlier, what's the easiest number to plug in? 0. In fact, you can probably maybe even do this in your head. If you plug a 0 in for the x, the 2x goes away, right? Absolutely. So then what we're going to do, how about just plug in a 0 in for the y value as well? And then we're going to plug in one more point. So it doesn't matter what number you plug in, any number you like. You can plug in a 1 for the x or the y. You can plug a 2 for the x or the y. I'll probably stick with those here. In this case, I'm just going to plug in a 4 for the y. Why a 4 for the y? The reason is because I know that way I'm not going to get a fraction. Okay, but if we do get fractions, that's still okay. All right, so, and again, I just made a weird one because you guys will plug something else in. You guys will probably plug in a 1 for the x. That's fine too. Right? Eventually, what we want to do is we want to be able to have the same exact line. If we have all the same exact line, we're doing good. Yep, the main thing is the straight line and not the points. Cool. All right, so plug in a 0 in for the x. And really, if you connect it back to 3.2, this is the way 3.2 was. Remember, you plug in a, this is kind of what we're doing here. 0 with a blank, then a blank with a 0, and then a blank with a 4. And that was sort of the same thing we were doing in 3.2. Cool. All right, so let's go for it here. 2 times 0 plus 3y is equal to 6. The 2 times 0 goes away, so technically we just have 3y equals 6. And I think I heard the answer for that one. The answer is after you divide by 3, just becomes a 2. Good there?
I already did the whole thing.
Ah, cool. All right, even better. Some people already finished. Okay, so plug a 0 in for the y value. And again, the 3 times 0 goes away, so 2x is equal to 6. Divide by 2, and we get ourselves a 3. All right, and the weird one. And again, the reason I put a 4, just to be very unusual. You guys maybe plugged in a 1. That's okay too. So plug in a 4 for the y value. Gets me 3 times 4 is 12. A little bit of algebra to do here. I got to subtract 12 from both sides. So 6 subtract 12 gives you a minus 6 or a negative 6. Divide by 2. Negative 3 is fine. Cool. All right. You may have got a different point for the third point, and that's okay. But go ahead and graph each of those points. All right, so I got 0, 2, 0 sideways, 2 up. Next one is 3, 0, so 3 to the right and up 0, or down 0, and then negative 3, up 4. And again, just to make sure those line up in a straight line. Absolutely. That's a cool thing. So let's draw a line. Again, making sure you have those arrows at the end. try another one here. Let me jump to this here. Sometimes what happens is you have something that's already been solved for y. In this case, because things are already solved for y, because we don't want to do algebra, it's a lot easier to do pre-algebra. Let's do this here. Let's not plug in for y. Let's actually just only plug in for x. And if you only get to plug in for x, then you're not doing any algebra. So first of all, easiest number to plug in again. 0 it is. What's the y value going to be? -1. Cool by me. Alright. At this point, whatever you like. Plug in whatever number you like for x. And figure out what y is going to be. Of course, I'm going to pick some strange ones here, so I'm going to do that first, to let you guys do that first here. Pick 2 more numbers for x, figure out what the y value would be. Alright, I'm going to plug in a 3, and again, it doesn't matter what it is, we should just look at the same line, right? So 3 times 2 is 6, subtract 1 makes a 5, and then I'm going to plug in a -1. And again, your numbers are going to be different from mine, and that's okay. So 2 times -1 is -2, -2 subtract 1 is a -3. As I start graphing this here, sideways 0, 1 down, 3 to the right, 5 up, and then -1 or 1 to the left, and 3 down. Let me just sort of guess. Let's just say if you guys picked a +1, I think you guys got out a +1. Is that right? And if you picked out a +2, I think you guys got out a +3. Is that right? Okay, if you did that, again, you would have had the same exact line as I did, and the line is the thing that's important. Okay, and another thing is, remember, all the numbers here that are on this line are the solutions to this equation, right? Even the halves over here, right? This could be like 1/2 0. This is I don't know, 1.5 2. Even square roots are in here. So all the numbers, all the coordinates that are on this line fulfill this equation. No matter if they're even whole numbers or fractions or square roots. They all fill that equation. Okay, one other piece that we have to think about is this little 2 right here. This was easy because you can really plug in whatever number you want for x. The difficulty slightly comes in is when this little 2 changes into a fraction. Then that's what we've got to do, a little bit different work here. Alright, so again, setting up our x and y. Again, easiest number to plug in? 0. What's the outcome going to be?
Y equals 1.
Yeah, y is equal to 1. Okay, now, let's think about this just for a little bit here now. If I don't want to see fractions here, and again, if you like, you can put in fractions, just have to do some extra work here with the fraction. But if you want to get rid of the fractions here, we have to get a number that 4 will divide. So we really just have to pick multiples of 4. 4 is a good one, isn't it? That's a multiple of 4, right? So let's plug in a 4 into that, and you guys tell me what that's going to equal as you simplify that further.
Are you on 3-3?
I'm on 3-3.
And that's number 3.
That's number 3.
My book says x plus y equals 3.
Mm-mm.
0.
I go with 0. It's going to be a, let's actually do the work here. Negative 1/4 times 4 plus 1. The 4's become 4/1. Makes a negative 1 plus 1. Something very similar to the example problem.
All right. Okay. Gotcha. Example.
Okay, negative 1 plus 1 makes a 0, and we're good to go there. Okay, now we need another multiple of 4. What do you guys say? 8. But the only problem is, look at this. Our graph only goes up to 5. This is 6. We've got 7. It's not a graph. Good. Negative 4, right? Negative 4 is still another multiple of 4. You can try negative 4. So yes, think about negatives, think about positives, think about either 4 of those guys. All right, and as you plug in a negative 4, you guys tell me what did you guys get? All right, got a few people saying 2. I would agree here. 4 and 4 cancels, leaving us with a negative 1 on top. Negative 1 times a negative 1 is a positive 1, and 1 plus 1 makes 2. All right, all yours. Plug or graph those 3 coordinates. They fall into a straight line, then connect them all with a straight line. Question is, if I put an 8 over 2 here for the x value, that would still be the same thing as 4. And you still get a 0, so you don't get an x. You don't get a different coordinate. Cool. All right. So 0, 1, 0 sideways, 1 up. This one is 4 to the right, 0 up. This one is 4 to the left, 2 up. And yep, that looks like they are all falling in line. That's cool.
I don't really understand. I think there's no graph and there's no negative 5 and positive 5 right in here. There's no graph at all, and you're giving that graph to solve, that one to solve. Why is it that we can't go beyond 5?
This is just the graph that was given on the match problems. But you can make your own graph. You can make it go out to 10. You could have plugged in the 8. Yeah, that's fine. I might give you a denominator of 8 over here. How about 1/8? And then at that point, I don't know if you want to go out all the way to 16, or you would just want to do a negative 8. Okay, we're good with that one? Let's go with... So this one is solve for y with a fraction as your multiply for x. So you got to sort of think about how that's going to work out. Let's go with one that we're eventually going to get a fraction out of. So I'll let you guys try this one. And this is more like just, let's try it all ourselves here. So you guys try, give you a minute here. Try it yourself here. Let's see if we come up with the same exact line. For this one, I am going to get a fraction for my third point, and that'll be okay. let's go for it here. I'm going to go for it here. So x and y, plugging a 0 in for the x should give me, hey, that's no fun. There's that fraction here. So let's see, I got to divide by -2. In that case, this is -3/2. And again, you really want to, leaving this as an answer, that's fine, but if you're going to be graphing it, you probably want to change it to a mixed number at this point. So let's see, it's a negative, so 2 goes into 3 once, with 1 remainder out of 2. Everybody okay with 1 1/2 negative? Plugging a 0 in for the y value, that's an easy one, because then now we'll just disappear the 2, x equals 3. And then I chose 2 for my x value, and again, you could have chose whatever you like. In this case, in order not to get a fraction, I probably would have plugged in something for the y value. That would probably be easier. But just to show you, that you can still do this even if you get a fraction. That's all I wanted to see. And again, as long as our lines match up, we're doing good. So 0 sideways, I'm going to go 1.5 down. So 1.5 would be between -1, -2. 3, 0 goes over here, a little bit more than halfway to 5. And then 2, 1, -1/2. So I'm going to go down just slightly right here. And again, as long as they all line up. Cool. All right, and we're good to go there. All line up, all straight line. Real quick here, is that the same line that you have? Could be different points, but as long as we get the same exact line, we're good. Okay, the next 3 problems are going to be sort of more like the weird problems here. So let's take a look at it. These are the 3 weird graphs that we have. Then we'll put it all together here. So first one is this one here. So 5a says y equals x. Again, sometimes confusing for students. That's why we'll just sort of do it together. Alright, so let's go for it. Bringing our x and y tables together here. Since y is equal to x, here's what happens here. If I plug in a 0 in for the x, guess what? I'm going to get a 0 in for the y. Ooh, got another little problem here then. Look at this. If that is the case, that means I can't plug a 0 in for the y value, because if I do that, I'm just going to get 0 for the x. It's going to be the same exact point. Bummer. Okay, so again, what I got to do is just plug in any other number for x, any other number for y, it doesn't matter. The thing is, since y equals x, if I plug in x is 3, what does y equal? 3. If I plug in a -2 for x, 2 for y. And again, you could have had different points there. But I got 0, 0, 3, 3, -2, -2, and I have a graph that goes like this. All right, if you want to write something over here, you just write this. You can say through the origin, because that's what this one is. It's what's so special about this line is it goes through the origin. Just write that in. And that's what makes this line special. The next special one, x is equal to 3/2. That's weird. So far we've been doing these guys. We had always an x and a y. This time I just have x by itself, nothing else. All right, so let's go for it. Let's think what in the world this means here. So since x is equal to 3 halves, it just means x is always 3 halves. The only thing is, I like to change it to a mixed number. So are we okay with 1 and 1/2? But this is what it means. X is always 1 and 1/2. It does not change. It stays constant. So x is always 1 and 1/2, 1 and 1/2, 1 and 1/2. You can't change x at all because x has already been defined. Okay, so let's go to here then. Let's go. Since there's no restriction for y's, guess what? What do we get to plug in for y? Anything we like. So how about a 0, a 3, a 5, a -2, a 6, a 1, whatever. Plug in whatever you like. Okay, now that you got those coordinates, can you graph it? Right, I'm going to graph it as well here. So 1 and 1/2 means that it's between 1 and 2, and it's at 0. So that's 1 and 1/2, 0. 1 and 1/2, 3 means I'm going to go up 3 units from here. There's my other dot. And 1 and 1/2, -2 means my third dot is down here. Do they still fall in a straight line? Absolutely. All right, what's so special about this guy? This is the vertical line. Okay, so real quick here, so we know vertical lines, we get vertical lines when the equation is missing the y value. Good? I think we'll see later on also is that whatever this x is equal to 3 halves or 1 and 1/2, this is exactly where it crosses the x-axis. So that's a little rule of thumb. Once you see the y missing, you know it's a vertical line, and you know it's going to cross the x right here. And of course the other one. Now this time the x is missing, so y is equal to -1. Alright, in that case, again, I'm going to make a little table. But this time the y is defined as -1 only and only -1, so it has to be -1 all the way down for the y values. The x values, doesn't matter. Alright, again, I'm going to plug in 0, 3, -2. You guys could have plugged in 1, 2, 3, or 0, 1, 2. That's all fine. And so 0, -1 is there. 3, -1 is 3 to the right, 1 down. 2 to the left, 1 down. And voila. There's my so special about this line, this is the horizontal line. Good there. I see a few more people still writing stuff down, so wait just a little bit. Okay. On page 194, if you want to turn to it, it has these special equations in the graphs, and this is the number 5 that we just did. So if you want to go back to it, sort of study, this is the equation of it. This is the line that goes to the origin. This is the equation that we're going to look at a little bit later on. There's your x is equal to a, and notice a is where it crosses the x-axis. And the y is missing here. Over here, the x missing, it's y is equal to b, and notice that's exactly where it crosses the y-axis. So just a quick, those are all number 5, 5a, 5b, 5c. All right, with that, that was 3.3. Moving on to 3.4. All right, 3.4, a very short section. We've got 3 problems to deal with here. This is just introducing you to something called the intercept method for graphing. If you think back to high school geometry, we know that it doesn't take 3 points to determine a straight line. It only takes 2 points to determine a straight line. So as long as we do the math correctly, we really just need 2 points. And we actually have already been doing it, so that's why it's a short section here. So we will learn 2 major ways to graph lines. One is called the intercept method, which is 3.4. And then 3.6, we'll call it the y-intercept method. That will be the other one. And these are the fastest ones. The reason why they're so quick is because you can probably not even write anything down. You could just look at the equation, graph the points. Got to do a little bit of mental math, but that's really what you want to get to. If you can do these next 3 problems without writing anything down, good shape. Cool. If you need to write stuff down, go for it. Usually if you have fractions on your hands, then you probably want to write stuff down. Okay. So let's go. First one here. So we're going to find the x and we're going to find the y-intercept. As long as we find those 2 points, we got ourselves a graph. And again, I'm going to write down sort of every single detail here, but if you can do it in your mind quickly, especially number 2, since you'll try it all by yourself. Number 3 is going to be a little bit different. But number 1, let's go for it here. So I'm trying to find the x-intercept, and what I do for that, I just solve the x when y is equal to 0. It's kind of like plugging in the 0 for the y, which is what we've been doing on the previous table. All right, so this is going to be x minus 3 times 0 is equal to 9. What is x? That's easy enough. There it is. All right, let's flip it around then. Let's plug in the, let's find the y-intercept by plugging in a 0 in for the x. And again, we made a little table last time of it, right? All right, if that's the case, x becomes 0, so I'm really solving negative 3y equals to 9 divided by negative 3. How about, good there? Okay, what we really want out of this is these 2 points right here. Since I got x equals 9, this means I have a coordinate called 9, 0. Right, plug in a 0 in for the y, gives me a 9 for x. Over here, I plugged in a 0 for the x. It gave me a negative 3 for y. Cool. We just need those 2 points. If we can get those 2 points, we're doing good. Cool. So 9, 0 would be about right here. Oh, I should mention one little thing right here. This is my little graph right here, and this is the graph that's on the matched problems on Math TV. Notice this one has 1, 2, 3, 4, 5 lines, but by the time you get to 5, it's already at 10. That means each one of these lines is actually worth 2. So we say this is scaled at 2. So in this case, this is 2, 4, 6, 8, and 9 is going to be between 8 and the 10, so it'd be about right here. And again, since you're making your own graph, no need to worry about that because you're making the lines yourself. Since we have a multiple choice test on our hands, I just might change the scale on you, okay? So kind of careful with that. Okay, 0, -3, which means 0 sideways and 3 down. So in between the -1 and the -2, there's my, I'm sorry, -2, -4, thank you. There's my -3, and connecting those with lines, putting arrows at the end, and you're done. All right, all yours here from beginning to end. Give you guys a minute or so. Find the intercepts, and then can you graph it? Let's go for it here. So plugging in the 0 for the y value should give you a -4 for the x. So there's my coordinate, -4, 0, should we be graphing? Going the other way, plug in a 0 for the x value, gives you 2y is equal to 12, or y equals 6, and there's my other coordinate. Everybody good though with the 2 coordinates at least? Maybe. Sometimes. So -4, 0, and again the whole situation again here is this is scaled by 2 here. That'd be a -4 there, a 6 there. Straight lines, arrows, and hopefully you have the same exact line that I do. Okay, the next one. Before we get to the next one here. So when do we use the intercept method? We use the intercept method when the x's and y's are both on one side and you have the constant term on the other. That's probably the easiest way to graph it. Real quick here, raise your hands if you were able to do this without writing anything down. 1, 2, 3, 4, 5. Say again?
I could have done it without writing it down, but now I just write it down out of habit. So
Got it, okay. So I got 6 people. 6 people were able to do this then, really out of just kind of plugging in a 0 here, noticing y equals 6, plugging in a 0 here, -4 for the x, graph it, done. That's exactly what you want. Intercept method, that's what it's made for. The next one is to show you that even if it's solved for y, you could still use the intercept method to do it. And again, this is not how we would graph it, but just to show you if you really needed to, you could still use the intercept method. This one would be the slope intercept method to do it, but we'll learn that next time here. So if we still had to do it by intercepts, we would still plug a 0 in for the y, but notice how long it's going to take. So let me do it with you guys here, since this is not really the usual way we do it. The y becomes a 0, and here's my problem. Now I have to use algebra to solve. Now I've added a whole bunch of different steps. So we're going to have to figure out a different method for whenever you have it solved for y already. Because this case, what I got to do is I got to multiply now everything by 3. 3 times 0 is still 0. 3 has to multiply into here, but the 3 is not cancel, so leaving you with 2x. The 3 also has to be distributed to the 4, so that gives me 12. Shoot, wait, that's 1, 2, 3. I'm into 4 steps already. I got to subtract the 12 to get it over here so that I can get it away from the x. So subtract 12. Now I'm into 5 steps. Divide by 2. Now finally into 6 steps to get this. Nah, not good. Too long. But I do notice one little thing here. In order to get the y-intercept, notice how easy the y-intercept is here. Because if I plug in a 0 in for the x, What's the y-intercept? Cool. Okay, so real quick here, in terms of if it's already solved for y, the y-intercept is the easiest to get to because it's just going to be the number in the back. And there's my coordinate. We good? So we'll sort of think on that. We'll look at that on Tuesday here. That seems to be the easiest method. Okay, let's graph them here. So again, 1, 2, 3, 4, 5, and we already get to 10. It's scaled by 2 again, but you guys get to make your own scale on your graph. So negative 6, 0 will be about right here. 0, 4 will be about right here. Again, straight line, arrows at the end, and we're good to go. Okay, and one more concept here, 3.5, whole concept of slope. That's what we want to get to. And then we'll put it all together in 3.6. All right, I just took this from the book here, the graphic here, about slope. Slope is really the steepness of the line. How steep is this line? And whenever we talk about slope, we always look from left to right, just like we read a book. We look from left to right, and as I'm looking from left to right, is this graph going up or down? It's going down. You're sort of like going down from a mountain. So we say this is going to be a negative slope. This one, if you think of a person walking, it's not going up, not going down. Level ground here, we say this guy has a 0 slope. Slope is 0, not going up, not going down. And then you get the positive slope. Again, going from left to right, it's kind of like climbing the mountain this time. You're going higher and higher and higher in terms of elevation. So we have ourselves a positive slope here. All right, we do have some formulas for it, of course, here. So how do we figure out the steepness of a line?
What about one that goes straight up and down?
Ah, good, we'll get those right at the end. So here's a little bit of the formula. Well, the one you probably need to write down is this one, all the way down here by the definition. But if we talk about the steepness of a line, how can we measure the steepness of the line? Well, we got to figure out how fast it's going up. We call it a vertical change, or we call it the rise. And then how far it takes to get it across, and we call it the run. So slope is really rise over run. But in terms of x's and y's, what's happening is I need to figure out the distance the y changes. So the formula says, look, I need to take my y2, then subtract y1. That's how my elevation has changed. Then I take my x2 and subtract x1, and that tells me how much I'm going across. And the question always comes up, Mr. H, if slope starts with an S, why in the world did we use the letter M for slope? Because 500 years ago, when this was sort of invented, it was the French mathematicians that invented slope. And so their word for slope started with an M. I forgot it was called mortaire or something like that. And so because of that, they used M, and sort of, because in math it's more like a symbol than a letter. And so we just sort of just kept that M, kept on going. So there's why the M. But this formula, very important, write it down if you haven't done so already here. So y2 minus y1 divided by x2 minus x1. And let me explain a little bit here about the 1's and the x's and the 2's and stuff. Alright, the why the 2 and the 1's is because the 2, it says it's the second coordinate, and so actually the second point. So we say y2, what we mean is the y coordinate of my second point, y1 means the y coordinate of my first point. Again, on the bottom, x coordinate of my second point, x coordinate of my first point. Which one's the first point, which one's the second point, it actually doesn't matter. Usually we just label them and keep on going. So let's start. Try one together here. Alright, normally what we do is we just label, and the first point we come to, that's going to be point 1. But it really doesn't matter. If you flip them a little bit here, that's okay. So that 3, because it was the first point, is the x-coordinate, so that means that this becomes x1. Since this is my first point now, this becomes y1. Good there? Since that one's going to be my second point, so this is going to be x2, and that's going to be y2. Alright, and just rewriting the formula here, so we have it on this slide here, y2 minus y1 divided by x2 minus x1. As long as we plug in values correctly, we are doing great. What I like to do, especially for M61 students, as you're sort of getting used to it, I like to do this here. I put parentheses, put a minus sign in between, on top and bottom. Therefore, all you really got to do is just sort of plug in the values here. The reason I like parentheses because sometimes we might have to change this little subtraction to addition. It kind of helps a little bit. If you don't want to do that, that's fine too. But just for starting out, it's a lot easier to think through. So let's plug it in. What's my y2? 7 is good there. What's my y1? -2. Perfect. Going down on the bottom here, x2, -1, and x1 is 3. Perfect. So notice right here, sometimes you want to switch into addition, sometimes you don't, depending on the numbers, depending what they're going to do for you. For the top, I probably want to do that. I probably want to add now a +2. That's 9, so easy. On the bottom, do I switch to addition as well? Cool, yep. Adding a -3, or you can say -3, either or is fine, but you should get a -4, maybe. Okay, the only thing we don't like with fractions here, we don't like negatives on the bottom of fractions. So you got to have a little choice here. You can either move that negative to the top of the fraction, so with the 9, or you can move that negative in front of the fraction, so it makes that. But notice it's kind of funny. Whenever you say it in English, you sort of mean the same thing. You say, this is -9/4, right? Or you can say -9/4. Right? You say the same thing, but the negative sign could be on top or could be in front. I do want to show you here that +9 over -4 is actually the same thing as -9 over +4, which is the same thing as a negative in front and 9/4. Those all these three are actually the exact same. The preferences, we write it like the last two. All right, all yours here from beginning to end. Try it yourself. So let's go for it here. Again, label it if you need to. That's the way I would label it right here. And the formula given and the numbers that should be going there is a 3, -3, 7, -5. And the only problem that usually happens with students is they get the numbers mixed up. But I think as soon as you label this, then you're really good. Okay, with fractions as well, you don't want to leave it if you can reduce it. So 6 over 12, so if you write 6 over 12, it would be wrong. You got to reduce it to its, we call it relative primes. In this case, just 1/2. Okay, another thing that this sort of helps us with, the whole concept of slope, is I really just need a slope and a point. If I get those two things, I can graph already. So notice we want to graph the line just given these two pieces of information. I have a slope of 2. I do have a y-intercept of 1. So if I have a slope of 2, normally with slopes, what we're going to do is we want to write it as a fraction. That's kind of what we want to do. So slope written as a fraction would actually be 2 over 1. We good? And again, the whole concept of rise over run. If the y-intercept is actually equal to -1, what's my coordinate? That's perfect. Yep. That means the x is 0 and the y is 1. Right? Okay, how does this work? I got to go with the y-intercept first. I'm going to graph a point that I know. So 0, 1. 0, 1 means I go 0 sideways, 1 up. From here, I just need to use my slope. Remember, because this is how it moves. I'm going to go from that point. I'm going to go a rise of 2, a run of 1. So rise 2. So from here, I go 1, 2. A run of 1. And with a run, we usually move off to the right. Put a little dot. Hey, how many points determine a straight line again? 2. Do I have 2 points? Absolutely. I'm done. Could I keep on going? I can still keep on going with this. I could have actually taken this point here and went up 2 units and over 1. I would have been right here. But notice it's still going to be on the line. So kind of give you a clue here for the next section here. I just need my intercept. I need my slope. In fact, I really don't need the intercept. I just need a single point somewhere and a slope, and I'm good to go. Okay, and the weird one. Let's do the weird one together here. I'll let you guys try it yourself first. Go for it until you get stuck. At some point, like, whoa, this is weird. When you say this is weird, just stop. Sorry, you need to fill out this little thing right here. 26, 3. Okay, let's go for it. So slope formula, there it is, and there's my parentheses with minuses in between. I got 11 minus a -6 on top. I got a 2 minus a 2 on the bottom, and that's the problem, that little 2 minus 2 on the bottom. If I change it to addition, I get 17. on top, but I get a 2 minus 2 or a 0 on the bottom. Can't divide by 0. So the answer is, the book defines it as no slope. Some other math textbooks, they would say undefined slope. That's kind of what we're looking at.
Can I ask a question?
Mm-hmm.
We've been doing a lot of changing from subtraction to addition. What determines when you decide to make that addition? Is
Sure.
it every single time?
Sure, 1 second. Let me finish this off. And then online, there's no such thing as no slope. What you're going to do is you're going to write D and E in capital letters.
There's no.
And that's what you're going to write down whenever you have a no slope situation. Okay, question came up is, Mr. H, notice a lot of times we change addition to subtraction to addition quite a bit. When do we do that? When do we not do that? It's whenever it makes it easier for you to solve the problem. Usually if you're subtracting a negative, like in this case, we want to do that because it makes it a lot easier to do. In this case on the bottom, notice I didn't do it. So 2 minus 2, or maybe this one was like a 5, 5 minus 2. I could still do that understanding subtraction from 4th grade. Perfect. If it gets a little bit more complicated, it's easier just to change to addition.
I got all the way to that point, but what I did was I put 5 over 4.
Ah, got it. Okay. So in this case, on the top, I would probably change this to addition.
Okay.
Just make sure. And now you know, like, oh, hold on, 11 plus 6, I know that's 17.
Okay.
This one you probably shouldn't even change because you know that 2 minus 2 is going to give you 0 right away. So in this case, don't. So if it's easy, you know, from grade school you can do it, go for it. And if it gets like, oh, I'm not sure, change it.
Okay.
Okay, with that one done, let's go through again these. Remember the special equations that we looked at earlier? Special equations. Now we're going to add some more information. Remember, this is a through the origin one. We got their equation. Now we know the slope of this line. We know that the y-intercept and the x-intercept are both zeros. This one, again, the no slope concept, that only is with the vertical line. That's connected to the vertical line. And then the slope that's equal to 0, that's going to be always connected with a horizontal line. Okay, we're good there? So it kind of made the connections between the graphs and now are their slopes for the particular special equations here. All right, and one little extra one here that I wanted to show, at least you guys to try here. This is comes off the homework. This is one on the homework here, but it confused students last semester, so I figured we should do it during lecture. Cool. Some of you guys already finished it off. That's cool. Not graphing it, just can you find the slope here? So if you have a x-intercept of 3, tell me if you guys agree, isn't that the coordinate itself? If you have a y-intercept of -2, what's the coordinate going to be? Cool, awesome. 0, -2, right? The y has to go in. It's always x comma y. Cool. And if that's the case, plug it into the formula. Not going to give it to you. Probably should have memorized it by now. So we're just plugging in some values here. And again, this one just sort of got people stuck last semester, so I figure we should include that in the lecture here. Let's see, y2 minus y1, that means negative 2 subtract 0. That's the way I would write it. Perfect. And then from here, it's going to be 0 subtract 3. So it's the y coordinates subtracting, x coordinates subtracting each other. I heard a negative 2 on top, because if you have a negative 2 and you're subtracting 0, you're really not subtracting anything. On the bottom, yeah, 3. In this case, I probably would change it to addition. Then we're adding 0, you're not really adding anything at all. So one of these is converting from x and y intercepts into coordinates. The other piece is the whole concept of if you have a negative on top, negative on the bottom, those will cancel each other out. So you should wind up with a positive 2/3 as your slope.